Okay, so today I am going to talk about properties of exponents, and the particular property we are going to talk about is quotient of powers. Well, first of all, when we talk about a quotient, we're talking about an answer to a division problem. So when you hear the word quotient, you think of division. But what you have to know is that a fraction is a division problem. And we also know that powers are the little numbers, the exponents that sit on the shoulder of the base number. So we're going to see today how that works. So for example, if I give you a problem that says x to the value of m divided by x to the value of n. What we are doing here is we're doing a division problem. This problem is a division problem, but the powers don't want to divide. So when you have a division problem and the bases are the same, x and x are the bases because those are the big numbers or the physically larger numbers that hold the exponents on their shoulder, as long as the bases are the same, the powers say, we don't want to divide. We want to subtract. So the way this works is that the answer is x to the power of m minus n, because the powers say, we don't want to divide. We want to subtract. So when the problem does division with bases the same, the exponents subtract. So suppose I gave you x to the power of 5 divided by x to the power of 2. That would equal to x to the power of 5 minus 2, which would give us an answer of x. Yes, exactly. I heard somebody say it. What did you say? X to the power of 3. You see? Now, I'm sorry. You guys are going to be upset, but I have to take this. Oh, Jesus, I missed it. Ay, 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 ay. All right. Can do. All right. So let's try that out with all numbers. Now, remember, the bases have to be the same. So suppose we had 2 to the power of 3 divided by 2 to the power of 1. We would get 2 to the power of 3 minus 1, which would be equal to 2 to the power of 2, which is equal to 4. Okay, because the powers say we don't want to divide, we want to subtract. Now let's prove that that is correct. The way that I can prove it to you is that instead of doing it out as the powers, you can say 2 to the third power is equal to 8, because 2 times 2 times 2 is 8. And on the bottom, 2 to the first power is 2, because any number to the first power is simply the number. And 8 divided by 2 is equal to 4. So you can see that this property really does work. But sometimes the numbers are easy and you can do it without using the property. If your teacher says to you, use the property for the quotient of powers illustrated, then you have to do it. But if the problem just says do this, You can do it any way you want if they only want the answer. But you need to know that it's the same. And sometimes these are a lot of work to do this way. So you do it that way. And sometimes this way, the numbers are just too big and you might do it using the power. Now I want to tell you a little story. And the story is real because the girl really was in my class before when I was in grades 2 and 3. But I kind of fabricated, like made up a little stuff about her when I started doing exponents because she was tiny. She was what we call a midget. A midget is a short person. They don't have to be ugly. They can be really cute. She was the prettiest girl you ever want to see. She had this beautiful golden skin, like more golden than mine or yours or yours. It was a pretty brown golden skin. And her hair was a nice brown, like a little lighter than your hair. And it was beautiful and it was long and it was wavy. And she was a midget. So when we were in second and third grade, she was so tiny that the other girls would sit her on their shoulder at lunchtime and walk around the playground with her on their shoulder. So she was like an exponent whispering in the ear of the base number. And so that's the real part about her. But then, because when I started teaching about exponents, I thought about her, I fabricated some more things about her, which aren't necessarily true. And I said that she would whisper in the shoulder of the girls and say, do what I say, and I'm not going to help you. And every time somebody was supposed to do something, she would say, no, we're not going to do that. We're going to do something different. So this is a division problem. So you say, what kind of problem is that? And Tiago would say, a fraction is a division problem. And she would say to the girls, we don't want to divide. We want to subtract. So if this is a division symbol, it has that, and it usually has 2 dots on it. And that's what the division symbol would look like. She would erase the 2 dots and say, no, let's just subtract. So when you see division, think of this girl. Her name was actually Beverly. Think of Beverly taking away the 2 dots and saying, we don't want to divide. We want to subtract. Yes. Okay, so there we have it. So let's see how that worked for us. And we will end this.